Here's a crazy looking propeller, and it actually works. If you look at a ship's propeller, you'll see blades spinning around a horizontal shaft. Water gets pushed backwards, and the ship moves forward. Some propellers can adjust their blade pitch to change thrust, but the principle is the same. Spin the blades around a horizontal shaft. It's the same basic design that's been used since the 1840s. But engineers love a challenge, and they created this completely mad-looking propeller. The blades are vertical and arranged in a circle underneath the hull, and each one continuously changes its pitch as the assembly rotates. That's a Voith Schneider propeller. With a conventional propeller, thrust goes in one direction. So if you want to turn, you need a rudder to redirect that thrust. And if you want to reverse, you have to stop the propeller and spin it the opposite way. A VSP can direct thrust in any direction, without rotating the entire unit or using a rudder. Forwards, backwards, sideways, even diagonally, all controlled by changing the blade angles, not by repositioning the propeller itself. So, how the heck does it work? The design goes back to 1926. An Austrian engineer named Ernst Schneider developed the concept, and Voith licensed it for production. It's been in use on tugboats, ferries, and research vessels ever since. A VSP is a disc mounted vertically under the hull. Around the edge of that disc are several blades, usually 4 or 5. Then the disc rotates at a constant speed, but as it spins, each blade continuously changes its angle. It's just like a helicopter rotor lying flat. The rotor spins at constant speed, but the blade's pitch changes, which controls the direction of thrust. Inside the rotor's casing, there's a control rod. This control rod connects to linkages, called kinematics, that attach to each blade. When the control rod shifts position, all the blades adjust their angles. Not all at the same angle, mind you. Each blade adjusts differently depending on where it is in the rotation cycle. Hydraulic cylinders push or pull the control rod to set those blade angles. The rotor casing itself is driven by the main engine through a bevel gear. The bevel gear drives a sleeve that's connected to the rotor casing. The whole assembly, rotor casing and blades, rotates together. So you've got two things happening at once. The entire assembly rotating at constant speed, and each individual blade changing its angle continuously. From above, you just see the blades moving along a circular path. At any moment, those blades can be set to 0 thrust, and the boat doesn't move. Change the blade angles, and you control the direction of water flow. Adjust the blades one way, the boat moves forward. Adjust them differently, the boat moves backward. Change them again, and the boat moves sideways. You never reverse the engine. You never wait for a rudder. It's convenient, right? And crazy cool. To actually control a tug fitted with Voith Schneider propellers, the captain uses 3 main controls: the steering wheel, the driving pitch levers, and the engine RPM controls. The driving pitch levers adjust how much the blades are angled. More pitch means more thrust. The steering wheel changes which direction those angled blades are pointing, which controls the direction of water flow. And the RPM controls set how fast the propellers spin. Higher RPM means more power. By combining these 3, the captain can point thrust in any direction, or hold the boat perfectly still without moving at all. Of course, all of this needs power. The tug we're looking at uses 2 medium-speed marine diesel engines. Each one is a 4-stroke engine with 8 inline cylinders. They both run at 800 RPM and produce around 2,700 kilowatts each. That's about 3,700 horsepower per engine. The engines can be built to rotate either clockwise or counterclockwise. In a dual-engine setup, each engine spins opposite to the other. This balances torque and improves maneuverability. The engines connect to the VSP through couplings that absorb vibration and allow the propellers to be disengaged while the engines keep running. This gives operational flexibility. You can keep the engines running without spinning the propellers, useful for when the tug is idling or preparing for a maneuver. So this type of propeller is incredibly popular on tugboats, and some fully electric variations have been produced for ferries. But if this propeller is so perfect, why don't container ships and tankers use them? Every ship should use them, right? VSP excels at low speeds and tight maneuvering, but at higher speeds it's less efficient than a conventional propeller. It's also more expensive to build and more complex to maintain. All those linkages, hydraulic systems, and moving parts require precision engineering and regular inspection. For a tug operating in harbours where maneuverability earns money, that makes sense. for a bulk carrier, spending most of its time going in a straight line across oceans, it doesn't. VSPs came to solve one problem: how to generate thrust in any direction without rotating the entire propulsion system. The solution was to keep the propeller's orientation fixed and change the blade angles instead. It's been working since 1926, though these days azimuth thrusters have become more common for new vessels. Yet, you'll still find VSPs on older tugs and some specialised vessels, but the technology has largely been overtaken by simpler alternatives. So, Voith Schneider propellers remain specialised. Tugboats, ferries, survey vessels and icebreakers. Ships that need to hold position, move sideways or rotate in place, and fine with a slower speed. For everyone else, conventional propellers still make more sense. Every episode on this channel takes days to produce, from research and scripting to storyboarding, animation, and even voiceover. And it's all made possible by our Patreon crew. We've just revamped our Patreon and we've prepared a lot more to share with you. As a deckhand, you'll get early ad-free access to new videos, be able to vote on upcoming video topics, grab exclusive wallpapers for your phone and PC, and see your name on our supporters wall at the end of every new video. If you'd like a closer look behind the scenes, the officer tier gives you time lapses of our team working hard on brand new animations or thumbnails. You'll also get behind the scenes updates, animatic releases, and a monthly newsletter filled with maritime stories and news that we don't cover on the channel. And for those who really want to take the helm, our captain tier lets you sail your very own custom designed ship in the casual navigation art style, featured in a future episode for everyone to see. You'll also get your name in the end credits as a captain supporter, with video shoutouts and private Q&A sessions on Discord. However you choose to support, or even if you're just here watching, it truly means a lot. You'll find the Patreon link down below. Thank you for keeping casual navigation afloat. Hopefully you've enjoyed learning about this type of propeller. If you want more content like this, be sure to subscribe. And until next time, thank you for watching.